Hello everyone! Hope you are doing great. Today, I will be sharing a project called Enhancing Document Retrieval with Contextual Overlapping Windows. Most vector search systems return small, isolated chunks of text. Even when they are relevant, they often miss the bigger picture. So in this project, I introduced a contextual retrieval method that fetches surrounding text along with the most relevant chunk. The system processes PDF documents, generates text embeddings using OpenAI, stores embeddings in a face vector database, uses a custom contextual retriever, delivers richer and more complete results. To access this project online, start by opening your web browser and going to the Google search bar. Type in Enhancing Document Retrieval with Contextual Overlapping Windows and press Enter. After pressing Enter, you will be redirected to the AIonlinecourse.com link. By clicking on it, you can access the complete project, where all the components are clearly organized and presented in a structured manner. The project includes detailed explanations, step-by-step guidance, and all the necessary resources to help you understand and implement the solution effectively. Now we are going to explore the project in detail. Let's get started. Google Drive mounting. First, we mount Google Drive in Google Colab. This allows us to access external files, such as PDF documents, directly from our Drive storage. By mounting the drive, we can easily load datasets and documents without uploading them every time. Installing required libraries. We install all the required libraries for this project. We use LangChain for document processing and retrieval, Face for vector similarity search, PyPDF2 for reading PDF files, and additional tools such as DuckDuckGo search and sentence transformers. Installing these packages ensures that our environment is fully prepared for building an AI-powered document retrieval system. Importing modules and OpenAI API key configuration. In this step, we import all the required libraries and LangChain components for our project. Then we securely configure the OpenAI API key by checking collab secrets or environment variables. Once the key is set, we finalize the environment setup and confirm that everything is ready to run. Loading the PDF document. We define the file path of our PDF document stored in Google Drive. This path allows the program to locate and access the climate change PDF for further processing. Reading PDF content into text. Here, we read a PDF file and convert its content into a single text string by opening the PDF, extracting text from each page, and combining everything into one output, which we use for further processing in our project. We use the function to read the PDF file and store all the extracted text in the variable content so we can process it further. Splitting text into overlapping chunks. After reading the document, we split the text into smaller chunks for easier processing, defining a chunk size and overlap to preserve context. Each chunk is stored as a document object with its index and metadata, so we can track its position in the original text. Then, we define the chunk size and overlap, then split the PDF text into smaller chunks using our function. These chunks are stored in the docs variable for further processing and embedding. Creating embeddings and vector store. We convert each text chunk into vector embeddings using OpenAI embeddings, then store them in a face vector database for fast similarity search, and also create a retriever to fetch the most relevant chunk based on a query. Retrieving a chunk by its index. We define a function to retrieve a specific chunk from the vector store using its index. The function searches through all documents and returns the one that matches the target index, allowing us to access chunks in their original order. We use the function to retrieve the first chunk from the vector store and print its content, allowing us to verify that our text chunks are stored and accessible correctly. Retrieving chunks with context overlap. We define a function to retrieve relevant chunks based on a query, and then include neighboring chunks to preserve context. The function finds the surrounding chunks, sorts them by their original order, and concatenates them while accounting for overlap. This ensures that each result sequence provides a richer and more coherent context for better understanding. Comparing baseline and context-enriched retrieval. We first perform a baseline retrieval by fetching the most relevant chunk for our query about deforestation and fossil fuels. Next, we apply the context-enriched approach, which includes neighboring chunks to provide a fuller, more coherent explanation. Finally, we print both the baseline and enriched results to see the difference in context and detail. Displaying retrieved context. We define a helper function to neatly display retrieved context. It prints each item and separates them with a line for better readability, making it easier to review the results. Demonstrating context-enriched retrieval on AI history. We define a sample document about the history of artificial intelligence and split it into overlapping chunks for processing. We then create embeddings and store them in a face vector store, along with a retriever for querying. We perform a regular retrieval to find the most relevant chunk for the question, when did deep learning become prominent in AI? And display the results. Use context-enriched retrieval to include neighboring chunks, providing a more complete and coherent explanation of deep learning's rise in AI. In this project, we showed how context-enriched retrieval provides better and more meaningful results than basic search. If you want to find more AI-based projects like this one, make sure to visit AIonlinecourse.com.